Hey everybody, welcome back to my channel. Today on the bench I have an early Hallicrafters model SX-99 shortwave radio receiver that I picked up at an estate sale for about 25 or 30 bucks. And as is, unknown working condition. So today we'll take a look at it, look at the overall condition. We'll bring it up slow on some voltage on a variac to see whether or not we can make the smoke genies come out. And if it needs some repair and it's not going to be too overly involved, we'll see if we can't get it up and running. I'm not going to go whole hog on this thing and do like a full alignment or anything like that. But if I can get it operational, then I'll probably offer it for sale and let somebody take it down the road further as far as restoration goes. Overall condition, I'd say, it's kind of a little rough. There's some scratches on the cabinet on the top I'll show you. But just to go over a couple of the quick specs about this thing, the Hallicrafters SX-99 is the general coverage receiver, and it tunes from 538 kilohertz to 34,000 kilohertz, or aka 34 megahertz, in 4 different bands. And it has so the ability to cover 80, 40, 20, 15, and the 10 to 11 meter bands. It features a 1/4 inch headphone jack, a large S meter, signal strength meter, band spread and tuning knobs. It has a receive standby switch so you can keep the tubes warmed up and ready to go, but not have the B plus going to the tubes. Has a multifunction on-off switch that gives you the ability to change the tone also. We have the volume, we have a built-in noise limiter, we have a crystal phasing knob, we have a reception button here to go from AM to continuous wave. So we've got a beat frequency oscillator in this thing. We've got selectivity switch. We can go from normal to crystal, broad or sharp. This is the band selector. And we have a sensitivity control. So not unlike a RF gain, and then if you switch it all the way up here, that turns on the AVC, or automatic volume control circuit. It's kind of like a automatic gain control. So if you get a really strong local signal you tune in, it won't overload it. And it weighs in at a hefty 29 pounds, so I think it just qualifies for the boat anchor radio moniker. Appears like this might be the original cord, I'm not sure. It's a non-polarized lamp cord. Always a little leery when I see these, especially on radios that have all metal cases like this. There are quite a few of these radios that are famous for being real widowmakers as far as having situations that could easily cause the case to become hot with AC and makes these a severe shock hazard. This has got a hinge top cover. I'm looking at these scratches here on the top. Looks like something was on the top here that's moved around a lot. Maybe an external speaker. And then we got some scratches here, and I'm wondering if that's from somebody sticking something in there and prying. There are vent holes on the sides here. So, oh. There we go. Well, I tell you, I like what I'm seeing on the inside here. There are no missing tubes. The dial strings are intact. So the variable capacitors are moving with the knobs, which is good. All the tubes appear to be present. So these right here are the tuning condensers, which they're basically large air variable capacitors. And this is a small trimmer to help match it to the antenna. I've got a tube diagram up here that's showing me that this is a 6SG7, given its proximity I would say this is probably an RF amplifier, so the first stage of amplification. And then over here we've got a 6SA7, so you're calling that the converter. That would be what's going to do the job of changing the incoming frequency, selected frequency after its first stage of amplification to the IF. And then we've got these two tubes here are, we get another 6AS7 right here and a 6SG7 here. These are going to be your first and second stages of IF amplification. So these are probably your IF tuning transformers right here. This little guy over here is a 6H6. So that is the detector. It also does the job of the automatic noise limiter, automatic voltage control, automatic volume control. This guy right over here, this is the 5Y3. This is the rectifier. This is taking the AC from the transformer and turning it into DC, and then it's being reared by this guy, which is the filter capacitor. This little guy over here is another 6SC7. This is the, what is that? Oh, okay, this is an audio amplifier and beat frequency oscillator in this tube. And then this is the audio output tube, which is a 6K6 GT, which means glass type. So here's that tube diagram. This is telling me that the input voltage is between 105 and 125 volts AC. So this is a little bit newer, as old as it is. It's still a little bit newer than the last one that I worked on. The last one was a real Widowmaker. That was one that was originally designed to be able to work on AC or DC voltage, because early on there were still a lot of households that were running off of DC power before Edison finally lost out to Tesla's design and Westinghouse. Oh, rather than break out my fancy schmancy Variac PR57 from Sencor, I'm going to use this very early Power Stat. This thing's so old that it has a non-polarized plug or cord on it for the input. So it's just what we need for a dangerous old relic like this. You know, I joke around about that thing, but that thing works perfect. I mean, I checked it with my DVM and it's spot on. Well, my DVM du jour today is another relic, not quite as old. It's from the digital readout realm, but it's still an early one. This is an early Fluke 8021. Alright, so for the first test, I'm going to leave the receive standby switch in the standby position, and I'm going to have the power in the on position, and I'm going to bring the Variac slowly from 0 volts up. This should only end up energizing the filament circuit. So what I'm expecting to see is the filament starting to light and some panel lights if they're not burnt out, if the bulbs are good. Alright, so I'm up to 40 volts and I'm getting some dim dial lights, which is good. And it looks like I'm not seeing filaments on these glass tubes yet. I'll bring it up to 60 and give it a second. Oh, the audio output tube is lighting. Actually, the audio output tube and the rectifier tube are the only two tubes that are glass tubes in this thing that I could actually see the filament in. And the rectifier is not going to do anything in the standby mode. Alright, so now we've got nice bright panel lamps. The looks like the bulbs for the signal meter are out. Alright, satisfied with that. Power this down. Now I'm going to switch it into the receive mode. So now when I power it up, that's going to energize the B+ circuits, the DC voltage circuits. So if there is a bad short or something, we should see some indication. I should have a current limiting bulb on here, which would be a light bulb in series with the circuit, but I'm just kind of being lazy today. Hopefully that doesn't come back to bite me. I'll just bring it up to 30 volts at first. it's a real severe short, I'll be able to hear the Variac starting to hum. And there's 40 volts AC. Still have the panel lights lighting. So there is no internal speaker on this. So I'm going to have to either hook up an external speaker or throw some headphones into it. Alright, so now I'm up to 60 volts, and what I'm going to do is I'm just going to let that kind of sit there and idle at 60 volts and give some of these old capacitors in here a chance to kind of wake up again. I want to rouse them from their deep sleep with a gentle nudge. I guess while I'm waiting, I can go scare up a pair of headphones. Alright, at 60 volts I didn't see any signs of anything bad happening, but I also didn't hear anything because I didn't have a speaker or headphones plugged in. I've now plugged in my test speaker into the headphones jack. I'm going to crank the volume all the way up, and I'll leave the power on, and I'm going to leave the receive standby switch and receive, and we'll start at 0 volts and come up slow again. There's 40 volts, there's 50, you can just see the tubes beginning to light. 60 volts, you can just hear a little bit of a pop in the speaker when I switch the tone control. 70 volts, there's 90 volts. Rectifier tube is lighting now. Alright, I'm up to 110 volts. Nothing happening right now though as far as sound. I know my speaker's got a good connection because I can hear that slight click when I switch the tone switch. Oh, a little bit of noise. Static. The boiler finally shut off. There's probably dust in between the plates on those tuning capacitors causing that noise. Let's throw a hunk of wire on here for an antenna. Alright, so there's just a copper wire coming out of a big hole in the back of the chassis, which is, I think, where there used to be a terminal strip for the antenna. So I'm just going to hang a test lead from the overhead light as a makeshift antenna.
Will provide a free no obligation. Any questions or concerns about your upcoming household or office building requirements, call Montana Canadian Stores today at 4.
Michael, this money is here for everybody who is down. My own apply. You certainly can, but there's a ton of paperwork. We have 20 years dealing with the victim compensation fund. We have a wonderful relationship.
Well, the AM broadcast band is working. It's a lot of that typical garbage you hear on shortwave now.
Completamente maravilloso. Que la gente, que el pueblo, que San Espíritu, que Cuba, que cubanos americanos hayan apoyado de corazón, y también cubanos europeos también que en Cuba, y siempre me gusta.
Oh, there we go. So I've got a audio transmission. That's on the that's on what looks to be the 4.6 to 13 megahertz band. So I forget how many meters that is, but There's WWV on one of the shortwave bands. Well, I think I'm going to call this video a wrap. There really wasn't much to do to this thing. I mean, I could clean up the controls, but even the filter cap, there's no hum in this thing or anything. So I think we'll just turn around and sell it.